In this video, we've got a couple of examples of exponential equations. We have 5x equals 4 to the 2x plus 1. So how do we solve that? Well, when we are solving for an unknown exponent, typically we will be taking the logarithm of each side as our first step, or one of our steps. Okay, you can take log base 10 or the natural log, which is log base e, or any log. I prefer to take log base e because a lot of times I just get in the habit of that because a lot of times we have a natural base e in an equation. So I'm going to take the natural base even though we don't have, I'm going to take the natural log even though we don't have a natural base there. So natural log of 5 to the x equals natural log of 4 to the 2x plus 1. Now, properties of logarithms says that we can take these exponents and put them out front now. And put them out front is really a non-mathematical way of saying that, but we're taking that exponent and multiplying it by the natural log of 5 here. So let's rewrite that. Now we have x times the natural log of 5 equals 2x plus 1 times the natural log of 4. Now, the natural log of 5 and the natural log of 4 are just real numbers. I'm just going to leave them as they are, and I am going to, let's see, I'm going to distribute the natural log of 4 and over on this side, and I have x times the natural log of 5 equals 2 times the natural log of 4 times x plus the natural log of 4. Okay, at this point we have numbers. Again, this is just a number, and this is just a number, and this is just a number. So I'm going to pause the video and come back with some approximations with decimals. And so now I've taken natural log of 5 is 1.6094, and 2 times natural log of 4 is 2.77259. That's still being multiplied by x here. And then natural log of 4 is 1.386. So we're going to subtract this from each side to get the x over on the left-hand side. So 1.6094x minus 2.77259x equals negative 1.1632x. I've rounded here, of course. And we still have left the 1.386. Okay, now just divide by that last, the coefficient of x. And the answer is x equals 1.192. The next problem deals with 2 to the third power times 2 to the negative x equals 0.426. Well, when you are multiplying like bases, as we have here, the bases of 2, you add these exponents. So this becomes 2 to the 3 plus negative x equals 0.426. The process of solving for an unknown exponent from this point becomes the same as over here. So we take the natural logarithm of each side, and then what we can write is, again, this can be moved out front, so we have then 3 minus x, instead of writing 3 plus negative x, 3 minus x times the natural log of 2 equals the natural log of this becomes negative 0.8533. I'll just round there. And now what I've done is divided each side by the natural log of 2 so that I can get 3 minus x by itself. I know I could distribute the natural log of 2, but I'm not going to. I'm just going to divide by natural log of 2, so I have 3 minus x equals this quotient, which would be negative 1.2311, rounding there. This came kind of fast for you. I'm just subtracting 3 from each side. So negative 1.2311 minus 3 is negative 4.2311. This is all equal to negative x. So x equals positive 4.231. I'll just round right there. I hope that helps.